In problem C2, people are always saying, oh, I can't visualize this. I don't think it's that hard, but you just make a little drawing. So David's pulling a box across the floor. So there's the floor, there's the box, and there's the rope David's pulling with. So he's pulling the box across the floor with 720 newtons of force. Since this is what he's pulling with, that's where the force that he's pulling with goes. It said that the rope makes a 17.8 degree angle with the horizontal. So our dashed line is the horizontal. So this angle in here must be 17.8 degrees. So that's easy. So if he's pulling at an angle there, of course, he's really pulling the box both sideways and up. Well, the box is not going to move in the direction he's pulling. The box doesn't start floating through the air like that. The box is going to end up moving straight sideways. So if the box is going sideways, then friction, of course, is trying to pull it the opposite direction of its motion. So friction is going to pull it this way. So the first question I ask is, what force is actually overcoming friction? Well, of the triangle over on the right side, only this part is fighting friction. This would be the anti-friction force, because friction is pulling straight this way, so the part of this that's pulling straight that opposite way is going to be the part that's fighting this. So if we look at our triangle there, then that looks like it's the adjacent side of this triangle. And again, when we use adjacent, we're always going to use cosine. So we're just going to say cosine 17.8 times the hypotenuse of 720 tells me that the friction force must be 686 newtons, which I guess there's only two sig figs in 720, so we're going to round that to 690 newtons. If you're not getting the right answer here, it's probably because you're not in degrees. Remember, calculator always has to be in degrees. Now, there was a second part to this problem. In the second part to this problem, it said if the coefficient of friction is 0.18, so if our mu is 0.18, and the box is not accelerating, if it's not accelerating, it's traveling at a constant speed. If it's traveling at a constant speed, then this force is my friction force, of course. So we want to know how heavy is the box. Well, of course, we remember from last week that Ff is equal to mu Fn, and if we're on a horizontal surface, which we are now, the normal force is just the weight of the box. So really, I'm just solving for this. So all I have to do is bring mu underneath the Ff. So I'm just going to take my 690, and I'm going to divide it by 0.18, and that should give me my weight, which looks like it would be about a 3,800 Newton box. So that's all you got to do for that.